Welcome to Introduction to Arrays. So what is an array? An array is basically a fundamental data structure found in most programming languages. Uh, they are a lot of times used for storing a collection of items. And these items are stored at uh, contiguous memory locations. I mean by contiguous memory location is that these elements are next to each other in memory location. And the idea is to store multiple items of the same type together, which makes it easy to calculate the position of each element by simply adding an offset to a base value. Um, Arrays can be used to solve many interesting problems, and we're going to talk about what are some applications that arrays solve. And arrays come up very often in interview problems. Before we go over an example and analogy, let's briefly go over the key characteristics of arrays. I know when we're giving you a definition of array, we cover these briefly. So there are four key characteristics. First is fixed size. Second is the elements in an arrays are of the same type, which means the elements are homogeneous. Third is indexed access. Fourth is contiguous memory allocation. So if I were to go over each characteristic in more detail, so what we mean by fixed size is that once an array is declared, its size is fixed and cannot be changed. So what this means to you is that you need to know the maximum number of elements you need to store in advance. Homogeneous elements or elements in an array that are of the same type. So you can only store the same type. So say your array is an integer array, then it will only store the type integers. If your array is a character array, then it will only store characters. Indexed access, what we mean by that is that each element in an array uh, is associated with a numeric index, which means you will use that numeric index to access or modify the element. And indexing typically starts at 0. We will go over that more in detail when we uh, look at like specific example of an array in uh, programming languages such as Java, Python. And lastly, contiguous memory allocation. So arrays allocate memory blocks contiguously, and this enables efficient access to elements. And by allocating contiguously, this allows indexed access that we talked about. That's why we can have numeric index. So let's talk about a um, bookshelf in a library. So let's imagine a bookshelf in a library, which each slot on the shelf representing a position in an array. Then we're going to talk about 5 things of this library. So first will be fixed number of slots, sequential slot numbers, slots fitting books of similar size, uh, easy to find and retrieve books, difficult to add or remove slots. So the first one, fixed number of slots. So the bookshelf has a fixed number of slots, let's say 50. So this is similar to declaring an array of a fixed size. And once this bookshelf is built with 50 slots, it's not feasible to add a 51st first slot without building a new shelf. So in a sense, this is similar to the fixed size nature of arrays that we talked about. And second, sequential slot of numbers. So if you imagine a shelf, each slot on the shelf is numbered sequentially from 0 to 49 or 1 to 50. If you are looking for the book in slot number 30, you can go directly to slot number 30 without having to go through, like, basically scan every slot from the beginning. This uh, kind of represent that direct access feature of arrays that we're gonna look at, and this arrays have indices to access elements and slots fitting books of similar size. So all slots on the shelf are designed to hold books, and typically there would be of a uniform size of a uniform type. So similarly, in an array, every element is of the same data type and easy to find and retrieve books. So if you know the slot number, you can quickly find and retrieve a book without having to scan all the books. This is similar to how arrays allow for quick data retrieval using indices. There is a downside, uh, which is difficult to add or remove slots. Say you have you want to add like a new slot to the middle of the shelf, and this shelf is full of book, then it won't be easy. You might have to like remove a lot of books, or you might have to shift uh, several books, or in the worst case, you might have to create the shelf all over again. So similarly in arrays, inserting or deleting elements, especially if you're inserting or deleting elements in the middle, it will be very inefficient, and uh, it will require shifting other elements, just like that bookshelf example, or you might even have to recreate arrays. So in conclusion, like bookshelf, an array is a collection of elements arranged in a specific order, elements being books, uh, order, specific order being slots. And you can quickly access an element, which is a book, if you know its position, slot number for this bookshelf example, and modifying the structure of the array, which for this example would be a bookshelf. It's like adding or removing elements. For this example, slots and books can be cumbersome and requires rearranging the existing structure. I hope this bookshelf analogy helped you understand the key characteristics of array, or what an array is conceptually. We will look at concrete example, but for now, like, let's really focus on understanding the concept. So we talked about bookshelf. Let's talk about a book. Like, what would be like an example of a book which would be which will be like an element of an array. So here is one example. So this example book would have properties such as title, year, writer, and description. And for this specific example, title would be The Social Animal, and it will be published in 2018, and writer will be Elliot Aronson and Joshua Aronson, and description is a book that goes over various concepts of social psychology. So this is just one example. You can think of other books and store in a bookshelf. So I'll cover little further nuances, uh, such as library as a whole and special types of books and books of different sizes and replacing a book. You can think of library as a whole as uh, array of arrays or multi-dimensional arrays. So a library with multiple bookshelves can be seen as an array of arrays. We usually call this as a multi-dimensional array. So each bookshelf, each shelf will be an array, can hold a series of books, which are elements, and this entire library will hold multiple shelves. And uh, special types of books, you can think of this as a specialized arrays. So just similar to how reference books might be stored differently for quick access, in programming, there are specialized arrays. If you've taken Java class, you might be familiar with dynamic arrays, sorted arrays that optimizes for certain operations. We'll definitely run into this when we go over some of the example. And books of different sizes. This would, if we think about it in terms of array, it's a memory allocation issues. Say uh, a bookshelf was to hold books of varying sizes. I know you might have a small novels and large atlases. It will be less efficient, and this is kind of similar to how arrays in programming are less flexible with different data sizes and types. And replacing a book, you can think of that as updating an element. So say you need to replace an old book with a new one in the same slot. Uh, it will be straightforward, and this is updating an element in an array, which uh, in programming is a simple operation. I hope this bookshelf in a library example kind of helps you give a better idea. Let me go over one more example. Uh, a row of mailboxes. Let's kind of imagine a row of mailboxes, maybe in an apartment building, all lined up next to each other. And you can think of each mailbox as an element in an array. Then this fixed number of mailboxes, you can think of that as a fixed size property of an array. So say when the row of mailboxes is built, there will be a fixed number of them. Since we used 50 last time, let's say 100 this time. So you will be declaring an array with a fixed size when you dealt with array in programming, and it's not easy to add a new mailbox into the middle of the row without reorganizing the entire structure. And each mailbox uh, has a unique number. So since we said that the row of mailboxes, when it was built, there were hundreds of them. So there will be numbers sequentially from, let's start from 0 to make it easy, 0 to 99. So if you want to access mailbox number 50, then you can basically do that directly without having to check every mailbox on the way, like starting from mailbox 0, 1, 2, 3, and so on to 50. You can just check mailbox 50 right away. So this is how indexing of an array work. And all mailboxes are the same size. So each mailbox, this mailbox that I'm talking about is designed to hold items of certain size and type, just as an array where every element is of the same type, like an integer array, string array. So it will be efficient for storing and retrieving mail. So similar to how the mailbox having a unique number, if you know the mailbox number, you can quickly and efficiently uh, put in the mail or take out the mail, just like how arrays allow quick access to elements using their indices. And adding or removing mailboxes will be problematic. If you need to add a new mailbox, it's not possible to just squeeze it in the middle. You will have to either rearrange or resize like the entire row mailbox. So similarly, inserting or deleting an element in an array would, if you're especially inserting, deleting in the middle, it will require shifting elements, which is very inefficient. So here is a mail example. So mail example might have like a sender information, recipient information, mail content, postage and handling, delivery status, whether it is delivered or in transit or on hold. Further nuances of the analogy. So overflowing mailbox would be similar to array overflows. So say if a mailbox is stuffed beyond this capacity, it won't be able to hold more mail, and you'll probably get notified from the person delivering mail, and the mails can like spill out or get damaged. So similarly in programming, trying to store more elements than the array can like lead to an array overflow, which is a common source of errors and bugs, and it leads to security issues. And we can think about empty mailboxes. So you uh, some mailboxes might remain empty, but we know that they still occupy space physically. So similar to that in arrays, even if some elements might remain unused, like you still need to have that contiguous memory allocation. That means it will still consume memory even if you're not storing anything. And special types of mail. Uh, let's imagine, say, some mailboxes are designed to hold not just like typical mail in a sense, like it's letters, but packages with uh, differing dimensions. You can kind of think of that as arrays of objects or structs in programming, where each elements of the array can store multiple pieces of data. And the mail example that we showed you, which contains multiple information, would be this case. We would implement this using like object structs. And let's say for multiple rows of mailboxes. So you can think of that as uh, post. You can imagine a post office. Post office might have several rows of mailboxes, and you can think of that as a multi-dimensional arrays in programming. So you might navigate through rows being first dimension, and then to specific mailboxes in a row. This will be the second dimension. Lastly, access restriction. You can only authorized person can access and modify the contents of the mailboxes, similar to how memory access in programming, it can be like restricted for safety and security reasons. Hopefully those two examples, a row of mailboxes and a bookshelf in a library, help you understand the characteristics of array better. So now let's talk about some advantages of arrays. There are 5 representative advantages. First is fast access and random indexing. Second is data cache friendliness. 3, memory efficiency and ease of iteration and manipulation. 5th, simplicity and use in low-level programming. I know when we are giving an analogy, we talk some of the advantages, but it's often helpful if we actually mention each advantage. So for the first, fast access and random indexing, one of the main advantages of arrays is their ability to provide fast access to their elements. And because elements in an array are stored in contiguous memory locations, accessing an element at any index is a constant time operation. And it's typically denoted as O1, which is talked about in Big O lecture. And this makes arrays ideal for situations where frequent reading of elements is required. Data cache friendliness. So due to their contiguous memory allocation, arrays are cache friendly. What we mean by cache friendly, we will need to talk about the modern computers CPU briefly. So modern CPU, what it does is it has like L1, L2, L3 cache, and they read memory in blocks. So when you access an array, a block of elements is loaded into the cache. So it will make the subsequent accesses to nearby elements faster because uh, there's a very highly likelihood of chance that the next element is already loaded, so you don't have to uh, read memory again and load it to CPU cache. And memory efficiency, so arrays, unlike other data structures, don't use extra memory to store any like metadata about like the size of the structure or provide connection between elements, which will be talked about in when we talk about other data structures such as like linked list. And this makes arrays relatively memory efficient and ease of iteration and manipulation. So with this straightforward indexing, arrays are simple to iterate over and manipulate, and this is very useful when you're using algorithms where iteration over elements is very frequent. And lastly, it's simplicity and use in low-level programming. So arrays are a simple and straight data structure compared to other data structures. Therefore, they are widely used in low-level programming because they provide direct access to memory and are a key component in representing data structures at a lower level. So we talked about advantages. Now let's talk about disadvantages. First one is fixed size. This will be probably like one of the biggest drawbacks. Once an array is created, you cannot change the size, which means you must know the number of elements that you are intending to store beforehand. And a lot of times it is not possible to know how many elements that we are storing for like specific programs, software that we're creating. And this could lead to either wasted memory if uh, the array is too large, or a uh, lack of space if the array is too small. Both cases are not ideal. And inefficient insertions and deletion. I know we talked about this when we're giving an analogy using bookshelf and row of mailboxes. Inserting or deleting an element in an array, especially in the middle, is not efficient. It will require shifting the elements to maintain the order. If you are curious about what the time complexity of this is, it's a linear time operation which has O of n, and this makes arrays less suitable for situations where insertions and deletions are frequent and random. And homogeneous data types, because arrays store elements of the same data type, this can be limiting when you need to store data of various types. Poor flexibility and scalability. So arrays lack flexibility. Resizing an array is a very costly operation that involves creating a new array with the different size and copying elements all over from the old array to the new one. And this makes arrays less scalable for some applications where the size of the data set can change dynamically. And direct memory access risk. So it's an advantage that direct memory access can be thought of as an advantage due to its performance, but with like a modern day application software, it also poses a risk because incorrectly accessing memory locations to which this happens a lot. You can think of it accessing an index out of the bounds of the array. I have done this multiple times whenever I create for loop. Like I'll often access an index out of the bounds. Uh, I'll probably make this mistake uh, again. And I'm sure some of you, when you learned for loop, probably ran into this issue. If this happens in real application, it can lead to bugs and vulnerabilities in the code. And this vulnerability can be exploited. And this is called like buffer overflow exploits. And there are, if you actually search on Google, there are just multiple cases of this exploit. Lastly, for this introduction to arrays, let me talk about some of the example applications. So since arrays are one of the most fundamental and widely used data structures in programming, and their simple structure and efficient access properties make them suitable for a very variety of application. You might be surprised like how many I listed out here. Um, so let's discuss some of these applications. So first, when you are like data collection and data retrieval, they both are kind of storing and accessing sequential data. So for data collection, arrays are ideal for collecting and storing data of the same type. So let's think of a like IoT device that measures the temperature of your house. Then the array can store a list of temperatures recorded either hourly or by minutes, and data retrieval. So because arrays allow for quick retrieval of elements at any given index. So any applications where fast access to data is crucial, you'd want to definitely use arrays. Uh, Arrays are used a lot when you're trying to implement like a mathematical concepts. So examples could be like a matrix operations or signal processing. If you taken math, such as like linear algebra, uh, arrays are often used to represent matrices, and two-dimensional arrays can represent like the rows and columns of a matrix, and enables operations like addition, subtraction, multiplication, and determinant calculation very efficiently. And signal processing, if you learn a little bit of like electrical engineering or have taken some intro courses, you might have ran into like a digital signal processing, and arrays would be a good data structure to use in digital signal processing because signals are represented as arrays of data points and for analysis and also for manipulation. For algorithms, arrays used in algorithm a lot. Two example I can think of would be like sorting and searching, dynamic programming. So for sorting and searching, a lot of algorithms which you will learn like quick sort, merge sort, and binary search. They use arrays inherently for their implementation due to their easy index-based access. And for dynamic programming, arrays are used to store like intermediate results in dynamic programming to optimize some of the recursive algorithms. So it's used a lot, and arrays, it's one of the simple data structure widely used. So it's used to implement other more complex data structures. some of the examples are that you will run into stacks and queues, heaps. You will learn more about stacks and queues and heaps for their like the lecture dedicated to them. Just to give you a little bit of overview in relation to arrays. To go over stack first, stack can be kind of implemented using an array where like elements are added or removed from one end of the array to simulate the top of the stack. You can do similarly with queues. Queues will also be implemented using an array where elements are added or removed from one end of the array. So it will be the end of the queue. And heaps, so for example, binary heaps, which are essential when you're trying to implement like a priority queue. It can be efficiently represented as arrays. And if we are to handle like multiple variables, like managing, such as like managing data sets or configuration storage, that can also use array. Probably what you will run into most would be like a string manipulation, like using character arrays. A lot of programming languages have this data type of string, and strings are internally represented as arrays of characters. This allows for efficient manipulation and traversal of text data. If you're into like a graphics and gaming, there are two examples: pixel representation, game development. So in the field of graphics programming, images are often represented as arrays where each element corresponds to a pixel's color value, and this color value could be represented from like 0 to 255, or it could use like a hex value. And game development, arrays can definitely be used to manage game elements. You can think of using array to store positions of all players on a game map. That will be an example. And lastly, for scientific and engineering applications, arrays are used. So data analysis would be an example. Arrays are like so crucial in scientific computing for especially storing large data sets for analysis. So it's used in like physics simulations or biological data processing. So in conclusion, you will be able to find arrays almost every field of computing due to their simplicity, efficiency, and the way they mimic contiguous storage in memory. And I've talked about a lot of application kind of ranging from basic storage manipulation to scientific calculation. So they're basically indispensable when you want to create a software. Thank you.